All right, so these two problems we're going to do in this video are basically the same type of idea. We're going to be using an algebraic approach to justify what type of quadrilateral this one is, okay, given these ordered pairs. So it's good to refresh our memory on how to plot an ordered pair. So let's do that. We've got 1, 3, so that's 1 for my x value, 3 for my y. That's point B. E is 7, -3. We got F is 1, -9. And I've got G, which is -5, -3. So we've got this wonderful looking quadrilateral here. And we're going to go ahead and show what type it is. Okay. So right now, right off the bat, I'm looking at it, I'm like, I'm thinking this thing looks kind of like a square or a rhombus, right? That's just what it looks like at first, but I do need to justify my conclusion. And what we mean by that is, take a look at slope, maybe even distance formula, to prove what it is. All right, so how about we start out with slope? That's real easy when it's graphed. I can just count it out, right? Okay, so let's take a look at G to B right here, okay? I've got to go up 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4, 5, 6. So my slope is 6 over 6, which is equal to 1. That's my slope of this guy. How about from B to E? If I count that out, I'm going to go down, because it's rise over run, so I'll start with the down. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Alrighty, so down 6, which would be a -6, and to the right 6, which is a +6. So that equals -1. There's my slope. And I can do that for E to F. I can count it out. This, and then what I'll end up getting is -6 over -6, which is equal to +1. And then when I go from F to G, I'm going to go up 6 and then over to the left 6, so that's -6, which gives me -1 for that one. So I've got a bunch of slopes which are 1 and -1. So what do I know first? Well, my opposite sides have the same slope, right? So the opposite sides are parallel. Okay, that's a start. Let me jot that down. Opposite sides parallel. Cool. All right, what else do I know? Well, with 1 and -1 as my slopes, that tells me that these sides are perpendicular because the slopes are opposite reciprocals. All right, so consecutive sides. Actually, why don't we do this? Let's say we got 4 right angles. Okay. So that leads me to believe if I got 4 right angles, that's either a square or it's a rectangle. All right, it's one of those two. Now there's a couple ways of going about this. I could do my distance formula for my sides, figure out what length they are, and if they're all the same, I know it's a square. Or my personal preference, what are my slopes and my diagonals? Well, this slope right here, it's a horizontal line, which means it's 0. This slope right here is undefined. Oops, let me put that in a different spot here. This slope is undefined. It's vertical. But in any event, what we know about this is these are perpendicular. And what do I know about the diagonals of a square? They are perpendicular. Therefore, I have a square. And my other reason would be diagonals are perpendicular. Okay? But in any event, I end up with a square on this one. Woo! That was pretty exciting. Again, we could have found our lengths of our sides. That's a totally fine way of going about it. I kind of hate using distance formulas, so I just stuck with my slopes and remembered my properties of my quadrilaterals. Alrighty, so we got one more problem here. What name best describes the quadrilateral? Use slope and properties of quadrilaterals to justify your conclusion. Alright, so again, slope is the name of the game here. It's the easiest one to work with, especially for graphing it. We can just count it out. You could always use your slope formula if you forgot what that is. That's the change in y, y2 minus y1, over the change in x, x2 minus x1. That is what our slope formula is. You can use that, but I prefer to really just count it out if I've got the graph right here, right? You know what I'm saying? Heck yeah. So let's plot all these points real quick. All right, so what do we have here? Well, first look, I'm thinking rectangle, right? It looks like a rectangle here. It looks like we got right angles, but again, we have to justify, okay? So how about we start with our slopes of all the opposite sides, or of all the sides, okay? So for BG, it looks like I'm going up 1 and to the right 2, so 1 over 2. And then for GH, I am going, let's count it out, down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So down 6 and to the right 3. Negative 6 to the right is positive, so positive 3. That simplifies to negative 2. So I've got 1/2, I've got negative 2. For LH, I'm going up 1 over 2, so 1/2. And if I were to count out from L to B, I'm going to be going up 6, and I'm going to be going to the left 3. So that would be, once again, actually, why don't I put it on the other side here? Negative 2. Cool. And I'm going to scooch all of this over 6 over negative 3, negative 2. Okay. So those are my slopes that I'm dealing with for all my opposite sides. So first off, my opposite sides are parallel. So it's at least a parallelogram, right? It's not going to be in the trapezoid family or the kite family. It's at least a parallelogram. So we're at parallelogram right now. So that's where my reasoning is. I've got 4 right angles. So 4 right angles. So it's at least now a rectangle. It's not, it wouldn't be a rhombus. I mean, I guess it could be, but then it would be a square because it's got 4 congruent sides. So I'm in the rectangle realm now. Is it a square though? Clearly does not look like a square, but we've got to justify. All right, so let's look at our diagonals like we did last time. If they are perpendicular, it's a square. If they're not, it's a rectangle. All right, so what are my slopes? So from B to H, I'm going down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. Okay. Let's double check that, make sure that's good. I think we are Gucci, yes. All right. So down 5 over 5. That's negative 5 to the right 5, which is negative 1. So that's one of the diagonals. What's my other diagonal? Why don't I do that one in the lovely purple looking color? We'll just redraw that. That one I'm going, looks like it's a lot steeper. 1, 2, 3, 4, 5, 6, and 7 over 1. So down 7, over to the right 1. That would be negative 7. Are these two slopes, these two right here, are they perpendicular slopes? Are they opposite reciprocals? No, they are not. They are not perpendicular. So 4 right angles, diagonals, not perpendicular, rectangle. All right, so we have justified algebraically that we have a rectangle here using solely the slopes of the sides and the diagonals. That was exciting stuff.